The Compact Coronagraph that was developed at the US Naval Research Laboratory is a small telescope that creates an artificial eclipse of the sun. And by doing so, we can observe the solar corona. A coronal mass ejection is a bubble of plasma that has an embedded magnetic field. That bubble of plasma can be suddenly released from just above the surface of the sun to the outer space.
These events, these coronal mass ejections, can have a real impact here on Earth and our technological infrastructure. They can affect our GPS navigation, they can affect civil aviation. Most importantly, these storms can affect our power grid. They can take down portions of our power grid, and if that has cascading effects on our technological infrastructure.
We've been keeping track of CMEs by using the LASCO coronagraph. The LASCO coronagraph has been launched in space on the SOHO spacecraft in 1995. So that's amazing that 29 years later, it's still working very well. But it's 29 years and it's about time for a replacement.
CCor is really unique because we've been able to package an instrument half the size with the same optical performance as our heritage research grade coronagraphs, like the successful NRL LASCO instrument on SOHO, the successful SECI package on the stereo mission, and it allows it to be able to be accommodated on a wider variety of spacecraft, allowing us to deploy a greater number of these in space.
CCor has enhanced NOAA's observational capabilities in a very major way. It is a big step for us now to have the images of the outer atmosphere of the sun every 15 minutes. That's a huge improvement on what we're doing now, what was done before CCor, in that we were relying on a ESA-NASA research satellite that can take up to 8 hours for us to get those images down. And so that really handicapped sometimes our forecasters from being able to see these events off the sun and give us the warning, that 1 to 3 day warning that our stakeholders need to take mitigative actions to prevent disruptions here on the ground.
So the CCor 2 that's launching next year on SWIFO will be placed at a Lagrange 1 orbit, and that gives us 1 million miles from Earth. That gives us more time to gather that data. It's also coming down in near real time, so it'll gather an image every 15 minutes. We'll bring that down near real time, be able to process it, and have very timely weather forecasts, and have more warnings to be able to send it out to the user community.
Now, looking toward the future, we need observing architecture that gives us a large view around the solar system. And so we're partnering with the European Space Agency for adding a third compact coronagraph over at the L5 position, which is 100 million miles away from Earth. And that's going to give us a stereo view of these CMEs.
As humans spend more time in space, as we expand our reach beyond low Earth orbit, detecting space weather is going to become a solar system-wide enterprise, where we're not just forecasting conditions here at Earth, but for astronauts in transit to either the Moon or Mars, space weather is going to be a critical capability to supporting those operations and to make sure those operations are conducted safely and successfully.
What is really exciting about CCor is that it took basically 18 years of research and development from when the idea was pitched by Denis Socher 18 years ago to when we finally collected the first images in space, and everyone was thrilled to see that it was working as expected.
Partnerships like this between NOAA and the Naval Research Lab, and also between NOAA and NASA, are critical for bringing in the right staff, the right technology, and making it more efficient and reducing the overall cost of these projects. This is saving us in the future. It's enabling technology to be built where those areas have the specialists.
We see our reliance on space weather forecasting increasing, not decreasing. We see how there's mega constellations being developed in low Earth orbit. We are planning for, as human beings, exploring out into space, in not beyond the protective shell of our magnetic field here at Earth, beyond the moon and out into the solar system. So we know we're going to need better and better space weather forecasting.